next thing we're going to do is take a look at two tangent line problems. And for the first one, I want to find the equation of the line tangent to this implicit formula at 2, 2. Copy down the problem and then go to Desmos so we can take a look at what exactly this curve looks like. I know that sooner or later I'm going to need the derivative of this thing, so let me just go and create the derivative and then I'll move into my whole tangent line thing. I want to do the derivative of 4 minus x times y squared, and I want to do the derivative of x cubed. Well, over here, 4 minus x times y squared, I need to go use the product rule on that. Actually, how about you take a moment, see if you can use product rule on this thing times that thing. I'll make the video pause. First, 4 minus x times derivative of the second, 2y dy dx, plus second, y squared, times derivative of 4 minus x, well, derivative of 4 is 0, derivative of negative x is negative 1, equals, well, the other side should be easy, derivative of x cubed is 3x squared. Let's see, to clean this up, I'm going to say 2y times 4 minus x. I think I'm not going to bother distributing. Doesn't really matter. I don't really care. 2y times 4 minus x dy dx minus y squared equals 3x squared. How about you take a moment and go solve that thing for dy dx? We've got 2y times 4 minus x dy dx equals 3x squared plus y squared. I'm going to divide and all that, and I'm going to get dy dx equals 3x squared plus y squared over 2y times 4 minus x. Is this totally wrong? No, I guess that is right. Sorry, not sure why I was doubting that. There's our formula for our derivative. For the tangent line, same thing we always do. Y minus y1 equals m times x minus x1. x1 and y1 are really easy because I told you it's 2, 2. As for m, I need to plug into my derivative, and the only difference between this and things that I did earlier was here there's an x and a y to plug in. The notation to show that I'm about to plug 2, 2 into dy dx looks like this. dy dx, a line, then 2, 2 means I'm about to plug in 2, 2. And this is going to equal 3 times 2 squared plus 2 squared over 2 times 2 times 4 minus 2. Take a moment, pause, finish this up, get the equation of your tangent line, and when you're done, go to Desmos, graph that tangent line at the same time as graphing that implicit formula, and make sure it truly is tangent. So this is 12 plus 4 over 4 times 2. This is 16 over 8. Oh, wow. Everything is just a 2 in this problem. Y minus 2 equals 2 times x minus 2, which is hopefully what you got. And when you graphed that, hopefully you saw, yep, it indeed was tangent to that formula that you were given. One more tangent line problem. We are going to find dy dx for x cubed plus 2x squared y minus 4y equals 7. Then write the equation of the tangent line at x equals 1. Take a moment, copy it down, go to Desmos, get the graph. Okay, well, we need to go find the derivative. I'm going to go do the derivative of x cubed plus 2x squared y minus 4y. I'm going to say that that equals the derivative of 7. I feel like at this point, you should probably be able to handle your derivative. So the video is going to pause, go find the derivative, and finish the whole thing off. Solve it for dy dx. Okay, so 3x squared plus 2, I'm going to go use product rule now, on x squared times y. First times derivative of the second is x squared dy dx, plus second times derivative of the first is y times 2x, minus 4, the derivative of y is dy dx, and on the other side we're getting 0. Going to distribute and get 3x squared plus 2x squared dy dx plus 4xy minus 4 dy dx equals 0. I guess I might as well move my dy dx's to the right because one of those is negative. Doesn't really matter though. 3x squared plus 4xy equals 4 dy dx minus 2x squared dy dx. 3x squared plus 4xy equals dy dx times 4 minus 2x squared, dividing and just switching sides because I like it better. I'm going to say dy dx plus 4xy over 4 minus 2x squared, and that's my derivative. Now, I want to find the tangent line at x equals 1. Y minus y1 equals m times x minus x1. And x1's really easy. x1's 1 because I told you it was. But I didn't give you a y. Any ideas how we can find our y value? What we're going to do is the same thing we would do in a normal tangent line problem where I would plug my x into that original formula to find y. I'm going to plug it in here to my original formula. It's just going to involve a little bit of work to find the y. To find y, I'm going to plug x into the original. That's going to give me 1 cubed plus 2 times 1 squared times y minus 4y equals 7. 1 plus 2y minus 4y equals 7. Oh, how about you go finish that and figure out your y value. And when you have it, tell me what the y value is. Let's see, 1 minus 2y equals 7, negative 2y equals 6. I'm thinking y is negative 3. Which means our point is 1 comma negative 3. Oh, you can't see that, sorry. Our point is 1 comma negative 3. To find m, well, you're going to plug 1 comma negative 3 into that formula for dy dx. Go do that and find your slope. dy dx is going to equal 3 times 1 squared plus 4 times 1 times negative 3 all over 4 minus 2 times 1 squared. This is 3 minus 12 over 4 minus 2. I'm thinking negative 9 halves for the slope. Hopefully that's what you said. And our tangent line then is y minus y1, y minus negative 3, so y plus 3 equals our slope, negative 9 halves times x minus 1. And there we go.